Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Today's lesson is tagged chemical combination. Okay, chemical combination. Now, this chemical combination, okay, that's today's lesson. By the end of the lesson, you will know the meaning and definition of chemical combination, the types of chemical reaction, and the types of compound. You know, your textbook at IJMB did not tell you the meaning or the definition of chemical combination, okay? Now, prelude. Now, chemical combination, you know, every compound is formed by combining one or two elements, okay? By combining one or two elements. And we know that every compound is a production of chemical activities. The next thing, the chemical combination is telling us how these chemical actins are joined together in forming a compound. Okay? How these two things are brought together in forming a compound. How do we combine those things chemically to give us a compound? The next thing, the end point of every chemical combination is the production of a compound. Now, what are these chemical things that are brought together? What are these things that are being made in the formation of compound? In essence, it must pass through a chemical change, pass through a chemical reaction before this particular compound can be formed. And that process where it does that is called a chemical combination. When you combine chemical things together to produce another thing, is chemical combination. For example, I like to use water. Hydrogen and oxygen are two chemical properties. They are two pure substances. Okay? They come together to form something. They coming together, they combining together alone in the reaction for the formation of water is called chemical combination. Now, what is chemical combination? A chemical combination is the reaction in which two or more elements or compounds combine to form a new product. In which two or more elements or compounds combine to form a new product. I told you that when they come together, when they combine, they must have to pass through a reaction. Okay? That chemical reaction, I told you, that leads to the chemical transformation of a set of certain substances to another. In essence, the reaction leads to a transformation. This reaction will lead you to getting a new product. Okay? Now, this particular reaction we see is a chemical reaction. Everything about this chemical combination is chemically combined together. It's chemically clinched together. Now, when this reaction takes place, okay, when this reaction takes place and the concentration of the reactants and the products are the same, it becomes chemical equilibrium. When this reaction takes place and the concentration of the products and the reactants are the same, in essence, chemical equilibrium must be attained. What do I mean? If you have carbon 1, oxygen 1, they come together and they form carbon monoxide. That particular carbon monoxide is an equilibrium. Why? Because the number of atoms in there are the same. 1, 1. they are the same. In essence, chemical equilibrium is a process whereby the concentration of the reactant and the product are constant. Chemical equilibrium is attained whereby the product, the concentration of the reactant and the product are constant. I take it again. Chemical equilibrium is attained when the concentration of the product, of the reactants and the products are constant. Chemical equilibrium is attained when the concentration of the reactants and the products are constant. If both of them are constant, then we attain chemical equilibrium. Remember, when this reaction is taking place, they have an energy, and that energy is called activation energy. Okay? The energy that is being used in chemical combination, the energy that is being used in chemical reaction is called activation energy. Now, this activation energy is what is being used in attaining chemical equilibrium, in attaining a new product. Okay? This is what the elements use. This is the energy they use in bonding together in order to achieve a new product. It's called activation energy. Now, it can be altered by the use of catalysts. The activation energy of a substance, or substances or products can be altered by using a catalyst. We know that a catalyst speeds up or alters a reaction and remains unchanged afterwards. So in essence, this catalyst increases the energy. It increases the activation energy for them to speed up and form a new product, different from the reactants. A compound can still be a reactant, because we said chemical combination is a reaction in which two or more elements or compounds combine to form a new product. In essence, compounds can still be reactants to form newer products. To form new products. And the types of the types of compounds and reactions, we will know how compounds are reactants. Now, take note. This particular reaction of chemical combination can be altered by using a catalyst. And chemical equilibrium is attained when the concentration of the reactants and the products are constant. Take note. Now, types of reaction. Remember, we said that a chemical combination is the reaction, okay? It's the reaction. Now, we must have to know the types of reaction that brings about the types of products. How do they combine in this reaction? Now, the first one is combination reaction. The second one is decomposition reaction. The third one is displacement reaction. And the last one is double displacement reaction. Let's talk about them independently. Combination reaction is a reaction in which reactants combine to form a single product. We say A plus B gives you C, water. Okay, A plus B gives you C, water. This is A, this is B, and this is C. It gives you water. It's just two elements coming together to form a product. Okay, so the A plus B. So the A plus B gives you AB. Sorry. A plus B gives you AB. Okay? Now the hydrogen is the A and the oxygen is the B. Okay? It's not C. It's a mistake. A plus B, A reacts with B, gives you a AB. In essence, the hydrogen is the A and the oxygen is the B. As you can see, the molecules or the strength or the size of the reactants did not change. Okay? The number of molecules, 2 atoms, came back as 2 atoms. So in essence, in a compound, they remain constant. So as you can see, this is chemical equilibrium. Now, the next one is decomposition reaction. As you can see on your screen, is a reaction in which one reactant breaks down into 2 or more products. Is a reaction in which one reactant breaks down into 2 or more products. In essence, this reactant is a compound, because an element we know cannot be broken by any chemical process. In essence, what can be broken is compounds. Okay, a compound that is being formed can be broken into two. As you can see, the decomposition reaction is being decomposed into different products, into different factions, into different species. Now, if you check, they say this AB gives you A plus B. Now, this one is sodium chloride. Okay, the sodium chloride gives you sodium and chlorine. These are the two things that came together to form sodium chloride. Now, this sodium chloride is AB. The sodium is A, the chlorine is B, and it gives you A plus B. That is what it gave to you. It has been decomposed and been broken into A and B. So you see on your screen, it's been broken into A and B. Now, this particular compound has been broken. Okay, it's a combination of A and B gives you AB. A plus B is AB. The A there is sodium, the B there is chlorine. Okay, now they broke it back. It has been broken back to A and B. The next one is displacement reaction. Displacement reaction is a reaction where a more reactive element displaces a less reactive one from the compound. A more reactive element displaces a more reactive element displaces a less reactive one from the compound. Now, we have copper sulfate. Copper sulfate. Okay? Either copper sulfate or copper tetraozosulfate 6. You're correct. Reactive plus ion gives you FeSO subscript 4 plus Cu. Now, when you check this particular reaction, you'll see that the copper has been displaced. Okay? The copper has been displaced. Why? Because the copper is less reactive than the ion. As you can see on your screen, you see how the elements are hitting that green one. That green one becomes the copper. They are telling him to get out from their side. He should go. Now, checking this, it gave you A plus B plus C equals to CB plus A. Now, this is A. The copper is A. The sulfide is B. And the ion is C. The copper is A, the sulfide is B, and the ion is C. Now, in every single displacement reaction, the first element in the reaction makes the sacrifice of displacement. Take note. The first element in the reaction makes the sacrifice of displacement. If they give you a reaction, okay, if they give you a combination or a reaction, and they tell you to bring out the displacement of that particular reaction, it's just the first element that you use in the displacement. Now, there's a law, there's a rule, okay? The rule is A plus B, AB plus C will give you CB plus A. If you follow every instruction, you're going to get every single reaction correct. It's not in your textbook, but it comes out in every international exams, be it your WAEC, be it your JAMB, or any exam you want to write internationally. Any exam you want to write. But it's not in your textbook, this thing I'm telling you. So, this particular reaction you're seeing, every reaction has a rule. And if you follow the rule and law of the reactions, you're going to get every single reaction correct. Okay? Now, the copper is A, the sulfur is B, and the ion is C. So the law says A plus B, AB plus C will give me CB plus A. Now, how do I get it? AB. What is AB? AB is copper. Okay? Okay, the law says AB, okay, plus C will give me CB plus A. Now, what is the AB? AB plus C will give me CB plus A. CB is what? CB is iron sulfide or iron tetraozosulfate 6. Iron sulfide. Plus what? A. The A there is copper. Gotten the answer. If you follow this particular thing, same applicable to sodium nitrate and potassium. Same applicable to sodium nitrate and potassium. Now, as you have seen, they said it's AB plus C. The A is copper, the sulfite is B, and the ion is C. Now, what is the A? The A is the ion, the B is the sulfite, and the copper is the C. This is your displacement reaction. The same thing applicable to the next one that we saw there, sodium nitrate plus potassium. If you check, the sodium is the C, reacted with the nitrate, which is the AB, and the sodium, which is the C, was displaced. Take note, every displacement reaction, the first element in the reaction makes the displacement. Take note. Okay, they said double displacement reaction. This is a reaction in which parts of the ionic compounds are exchanged, making a new one, making a new compound. In essence, they say the ionic compounds. Okay, now this particular compound have charges. All right, they have charges. In essence, the positive will react to the negative, and the negative will react to the positive in this compound. Now, they gave us hydrochloric acid or hydrochloride, okay, and sodium hydroxide. Now, if you check, the hydrogen is A, the chlorine is B, sodium is C, and hydroxide is D. This hydrogen has a positive sign, the chlorine has a negative, sodium has positive, and hydroxide has a negative. Now we know that these particular signs that have been up there is the ions, okay? They are the charges. Do you understand what I'm saying? They are the charges. In that context, these charges must have to be displaced in giving us new ones. Now, the hydrogen now is A, the chlorine is B, sodium is C, and hydroxide is D. Now, if you check, these two things came together, okay, ionically. The hydrogen reacted with chlorine, the sodium reacted with hydroxide. Now, looking at this very well, okay, you see that the positive must have to react to the negative, and the negative will react to the positive in making a double displacement reaction. Because they say the ionic compounds are exchanged. In essence, the charges are exchanged. So it will be A, it will be AD. Now the A will react with D, and the B will react with C. In essence, it will be AD, it will be BC, okay? It will be BC plus AD. That will be our answer. It will be BC plus AD. Now, if you check the B has a negative sign, and the C has a positive sign. So in essence, both of them will work ionically. Remember, like charges is not electrical. Opposite charges is electrical. So the the B there is chlorine. Now the chlorine reacting with sodium will give us sodium chloride. While the hydrogen reacts with hydroxide will give us HOH. Okay? And HOH, bringing out HOH, is H subscript 2O. The hydrogen is 2 and the oxygen is 1. Now, this is how we got this particular double displacement reaction. Take note, the thing is BC plus AD. That is the rule. Okay? BC plus AD is the rule. The ionic compounds are to be exchanged. The positive hydrogen was exchanged to meet the negative hydroxide, while the chlorine the negative chlorine was exchanged to meet the sodium. So applicable to the next one. If you check there, it's the same thing. The hydrogen there reacted with the oxygen that is negative, and the sulfide reacted with the potassium that is positive. Now the next one, we have types of double displacement reaction. Okay? The first one is neutralization reaction. It's the reaction between acid and base to form salt and gas. Acid and base. For example, hydrochloric, I brought it there in the screen there, you're seeing it there. Hydrochloric acid is an acid. Hydroxide is a base. It gives us salt and water. Water can still be tagged as a gas because it is two gases that came together and formed water. And in the process of evaporation, water is a gas. So water exists in both solid, liquid, and gaseous state. The solid part of a water is when it's being freezed. When it's being freezed, it becomes a solid. When it's evaporating, it becomes a gas. And its original state of matter is a liquid. So neutralization is a process whereby a base reacts with an acid to produce salt and water. That's neutralization. So neutralization reaction typically talks about when the acid reacts with the base to produce salt and water. They have to, that is the same thing we did here in the double displacement reaction. Okay, they gave us salt and water. The hydrochloric acid reacted with sodium chloride, sodium hydroxide. Sodium hydroxide is a base, and hydrochloric acid is an acid. It gave us salt, which is a sodium chloride as a common salt, and water. And this particular reaction is called neutralization it is called neutralization reaction, and it's still called double displacement reaction. Now the other one is precipitation reaction. It's a reaction in which, in an aqueous solution, two ionic bonds combine, resulting to the formation of insoluble salt. In essence, double displacement reaction produces salt and water. Sodium nitrate is a salt. Okay? Now, insoluble salt. This one is telling you that the salt cannot, as you're seeing on the screen, the salt did not dissolve in the water. In an aqueous solution, I told you, is a solution where the solvent is water. Okay? Now, in this reaction, it must have to be in an aqueous solution. And the ionic bonds between the silver nitrate and the sodium chromate forming together gave us two different things. But the particular salt they formed will not dissolve in water. It's going to be an insoluble salt. In essence, it's going to precipitate. It will not dissolve. While the first one dissolves, the acid dissolves in the water to form salt and water. The acid dissolves in the base to form salt and water. But in this one, the ionic bonds will combine to form a salt that is insoluble. The first one formed the salt that is soluble. The second one will form a salt that is insoluble. So these are the two types of double displacement reaction. Now the next one, we come to the end of reaction. Next one we say types of compounds. Types of compounds. We have 4 types of compounds. It is not in your textbook. Like I said, what I'm telling you is not in your textbook, but it is being set by international examination bodies. So you take note on that. The first compound is molecular compound. The second one is ionic compound. The third one is intermetallic compounds. And the fourth one is coordinate compounds, still known as complexes. Now the first one is molecular compound. A molecular compound, as you can see, is a compound that consists of molecules whose formula represents the actual number of atoms bonded together in the molecule. If you see on your screen, what we used is water. Okay? Now, if you check the formation of water, it's just the same thing. Gives us H subscript 2O. If you check, It says the compound that consists of molecules whose formula represents the actual number of atoms bonded together. If you check the actual number of atoms bonded together in water, as you can see, is clearly stated. You know that it is 2 atoms of hydrogen, or you know that it is hydrogen molecule that bonded together with the oxygen to form water. As you can see, we have the carbon dioxide, we have the carbon monoxide, and we have the water. As you're seeing it, from the particular compound, you know the actual number of atoms that were bonded together. For carbon dioxide, you know that it is 1 atom that was bonded to 2 atoms to give you carbon dioxide. For the carbon monoxide, you know that it is 1 carbon that was bonded to 1 oxygen to give you the carbon monoxide. So this is a metallic, this is a molecular compound. Now, first of all, for a compound to be formed, there must be a bond, okay? They must come together in forming a bond. You understand that? They must come together in forming a bond. There must be an attraction, okay? The carbon must be attracted to the oxygen before the bond will be formed, okay? Now, the bond that exists in molecular compounds is called covalent bond. It's called covalent bond. Covalent bond. Co, that means come. Both of you should come. 2. Okay? Valent, bring. So the 2 bonds should come together to form the molecular compound. It's called covalent bond or intermolecular bond. Either you call it covalent bond or you call it intermolecular bond. So instead, the bond that exists or the bond that makes this molecular compound, okay, the bond that binds them together is called covalent bond. And the covalent bond is the mutual sharing of 1 or more pairs of electrons between 2 atoms. Take, for example, I bring hydrogen and oxygen. I always use water because it's the simplest form of explanation. I bring water, hydrogen and oxygen, okay? The hydrogen will bring out its own pair of electrons. The oxygen will bring out its own pair of electrons. They will now be shared them. They will now share them into the hydrogen and oxygen. When it's being shared, that sharing will bring an attraction. And it's going to form a bond for the water to be produced. Now, this covalent bond or these molecular compounds are mostly, okay, known with non-metals. Okay, they are mostly gases or liquids that form this particular covalent bond or that form this particular molecular compounds. Molecular compounds are formed between 2 electronegatives. Okay, electronegative simply means they don't have charges. We talked about metals and non-metals when we talk about elements. Okay, these particular elements are not electrically charged. Okay, they are negatives. They are negatively charged. Every single non-metal is negatively charged. Okay, now this molecular compound, like I said, are basically with non-metals, basically with electronegative substances, basically with electronegative elements. 2 electronegatives coming together to form a compound. Carbon and oxygen are 2 negative metals. 2 negative substances. They came together to form carbon monoxide. So they are basically with gases and liquids that form this particular molecular compound. Remember, molecules are neutral. In essence, anything that concerns a molecule must be neutral. So these particular compounds are neutral. They are not electrically inclined. So, like I said, it is the bond that makes this molecular compound possible is the covalent bond, as we see. Okay? Now, for a bond to happen, there will be a force that will drag it. That force is called intermolecular force. The force that brings these particular elements together to form the bond is called intermolecular force. Intermolecular force is a force that exists between atoms and molecules. Intermolecular force is a force that exists between atoms and molecules. It is a force that brings atoms and molecules together to form molecular compounds. And the bond that they get because of this force is called covalent bond. Take note. The bond between them, because of this force, is called covalent bond. And the force that makes this bond possible is called intermolecular force. Now, I said there's one bond, okay, that exists in this electronegative mostly. It's called hydrogen bond. Okay, the hydrogen bond. Why I call it hydrogen bond? Because the hydrogen reacts with almost all the non-metals in the periodic table. Almost all the non-metals. Okay, this hydrogen bond reacts with almost all the electronegative elements. Now, the hydrogen bond is defined as the bond between hydrogen and electronegatives. The hydrogen bond is defined as the bond between hydrogen and electronegatives. What do I mean? Hydrogen and non-metals, hydrogen and gases, hydrogen and liquids. Okay? Hydrogen and any single element that is not a conductor. Now, that bond is called hydrogen bond. And the force that brings them together, that brings the hydrogen and the electronegative together, is called the van der Waals force. In essence, the van der Waals force is the weak force of attraction or repulsion between atoms and molecules. Remember, atoms are neutral, molecules are neutral. In essence, everything about the hydrogen and other elements will be neutral. Why? Because it is the van der Waals force that binds them together. Take note, the hydrogen bond, okay? And take note of the covalent bond. Take note of the intermolecular force. Take note. Now, I said, this is the mutual sharing of one or more pairs of electrons between two atoms. Now, if this covalent bond, if this sharing of the electrons between the two atoms are equal, it becomes a polar covalent bond. In essence, a polar covalent bond is defined as the equal sharing of electrons between two atoms. If they are not equal, the sharing of electrons are not equal, like for example, hydrogen and oxygen producing water, they are not equal. Hydrogen 2, oxygen is 1, so they are not equal. If this particular thing occurs, it becomes a non-polar covalent bond. That means to say a non-polar covalent bond is the unequal sharing of electrons between two atoms. Take note. Now the next one is ionic compounds. Ionic compounds. Ionic compounds are composed of ions held together by electrostatic force termed ionic bonding. Now, this ionic compound, they talk about ionic, they're talking about exchange of charges. Exchange of charges. We talked about double displacement reaction. Okay? The double displacement reaction most time produces ionic compounds. Now, exchange of charges, exchange of ions. If you check on your screen, okay, you will see that there's an exchange of ions. Okay? Now, this particular compound is always formed by a positive charged element and a negative charged element. We know that the ions are made of the positive charge and the negative charge. Now, that means to say it will be between a metal and a non-metal. Why? Because the metals are positively charged, while the non-metals are negatively charged. Remember, the non-metals I told you are gases and liquids. In essence, they are negatively charged. Now, check sodium hydroxide. Sodium hydroxide, the sodium is positive and the hydroxide is negative. The next one is sodium chloride. The sodium is positive and the chlorine is negative. But chlorine is a gas and sometimes turned liquid at room temperature. Magnesium chloride. Magnesium is a metal, chlorine is a gas. Calcium chloride. Calcium is a metal, chlorine is a gas. Okay? Sodium hydroxide. Hydroxide is a liquid, sometimes can become a gas too, and sodium is a metal. In essence, these particular ionic compounds are formed between two electronegatives. When the two electronegatives are high, okay, when they are high, the ionic compound is being formed. As you can see on your screen, there's an exchange between sodium fluoride. Okay, the sodium is giving a charge to fluorine for them to form a compound. In essence, these electronegatives in this context simply means the opposite charges, positive and negative. In this context, every single word in science or in chemistry has a meaning according to what you're talking about. So in this context, electronegative simply means the difference in their charges. So when the difference in their charges are high, they form this ionic compound. Remember, ionic compounds are now the force, okay, the force that brings them together to form a bond is called electrostatic force. Electrostatic force. Electrostatic force is a force that exists between ions. In essence, exists between the positively charged and the negatively charged. Or it is a force that exists between electrically charged particles. Anyone you want to take is your own. Either you say it's a force that exists between ionic compounds or between ions, or you say it's a force that exists between electric charged bodies, or you say it's a force that exists between a positive charge and a negative charged body. Anyone you want to use, you're correct. Now, there is a bond that binds them together. The force brings the bond. The force brings the attraction. Remember, force is an attraction. Okay? It changes the body state of rest. So it is a force that attracts you to anything. Now, that force attracts this particular metal and non-metal, bringing them together to form a bond that will give us a new substance. And that bond is called ionic or electrovalent bond. It's called ionic or electrovalent bond. As you can see on your screen, the force of attraction brought these two things together and they gummed and gave us a compound, ionic compound. Ionic compounds are electrically charged. Okay, they have a high level of electricity because charges repel and opposite charges attract and gives us enough electrical substances. Now, ionic bond is a type of linkage formed from the electrostatic attraction between charged ions in a chemical compound. That electrostatic attraction is called electrostatic force. They are the same thing. It is the attraction, it is the force that brings the attraction. It says the linkage formed from the electrostatic attraction between charged ions in a chemical compound. The charged ions are the positive and the negative. When they come together, they give us a charge. So that particular bond that gives us a charge in a chemical compound to form an ionic compound is called electrovalent bond or ionic bond. Now the next one is intermetallic compounds. Intermetallic compounds are formed by two or more elemental metals with definite proportion. I give you an example as magnesium stannite, magnesium plumide. Okay? Now these compounds are formed with two metals. Mostly when you want to make an alloy. Okay? We talked about alloys in the introduction to chemistry. Okay? Now these compounds are formed basically when you want to make an alloy. Remember we talked about using steel and dipping it inside zinc. Okay? It formed an intermetallic compound, and that intermetallic compound was used as an alloy. Remember when you use magnesium in increasing the strength of aluminum. Okay? These two things come together in definite proportion. Okay? Bringing the different proportion of, let's say, steel and the zinc. Okay? The steel you want to use as an alloy will be bigger than the zinc you want to add as an alloying element. Remember, the steel will become the base metal, and the zinc will become the alloying element. So any compound formed or any alloy you see is an intermetallic compound. Why? Because it is formed with only metals. This compound are formed with only metals. Now, the bond that binds them together is called a metallic bond. Metallic bond. Okay? It's a type of bond formed between positively atoms in which the free electrons are shared among a lattice of cations, of cations. Now, they say positively atoms are metals. Every single metal is a positive atom. And every single non-metal is a negative atom. I told you that. Now, this particular bond is formed only with positive. Okay? When in which the free electrons are shared among the lattice of cations. Now, lattice of cations simply means when the electrons surround, or when the anions surround the cations. Okay? When as you can see on your screen, you see the positively charged and the electron cloud, negatively charged. Okay? The electron cloud, we know that when the electrons surround the nucleus of an atom. Now, the positively charged ions are being surrounded by the electron cloud. In essence, the electron cloud are small, giving the positively charged ions a particular charge in order for them to be bonded together. In order for them to be bonded together. So in essence, the electrons are going freely, dropping each particle on each cation, so that there will be a little bit of charge for this bond to occur. Remember, like the magnetic, positive and positive do not bring a bond. Okay? Positive and positive do not attract. In essence, there will be no bond. When like charges come together, there will be no bond, because there will be no attraction. It's only when the negative and the positive come together there will be a bond and there will be an attraction. So this metallic bond is being formed by metals alone via the electrons dropping particles of itself on the cations for a bond to be effective. Now the other one is coordinate compounds or complexes. A special class of compound in which metal atoms are bound together to a number of anions or neutral molecules. Example, potassium ferrocyanide, pentamiclodocobalt dichloride are two examples I brought out to give to you. Now, these complexes, okay, these complexes or these coordinate compounds are metal atoms, but these metal atoms are bonded with neutral substances. They are not bonded with atoms that have charges. Okay? But sometimes they can be bonded with anions, but in a minimal range. They always bond with molecules that are neutral. Now, take for example, the potassium is positive, but the ferrocyanide is neutral. Why? Because the ferrocyanide is a combination of two gases. In essence, they are neutral, and the potassium is a positive sign. Bringing them together, they will give you a coordinate compound. So the formation of a coordinate compound is between a metal atom, which is positive, and a neutral atom, which is a molecule. So the positive charged atom reacting with the neutral atom to form a compound. And the name of that compound will give you a coordinate compound or complexes. Now, the bond that binds them together is called a dative covalent bond. Either I call it dative bond, dative covalent bond, or I call it coordinate bond. It's a covalent bond in which both electrons come from the same atom. In essence, that bond is neutral. Because if both electrons come from the same atom, then that bond will be neutral. Why? Because the electrons in the atom have the same number of protons and the same number of electrons. It has the same number of positive and negative charges. Their charges are equal. If the proton is 10, the positive will be 10. So in essence, this particular bond is a neutral bond. That is why it affects, or that is why it can react with the molecules that is neutral. Thank you very much. We have come to the end of this class or this lesson. But before we go, we should look at our exam guide in taking some questions to quantify what we have learned. Now, this is 2005. 2005, let's see question 15. Question 15 says the activation energy of a reaction can be altered by I told you in the prelude of the chemical combination that every single reaction, for the reaction to be to speed up, okay, a catalyst must be involved. Okay, the catalyst will speed up the reaction, and we know that it's going to remain unchanged. It will not be changed. It will not be consumed by the reaction. But all it does is going to speed up the activation energy, like I told you, that the energy that the compound uses, okay, the energy that the compound uses is in making its bond. It's called activation energy. So this answer here now, we have adding a reducing agent, applying a high pressure, we have using a catalyst. Using a catalyst. So a compound, activation energy of a reaction can be altered by using a catalyst. Let's go to the next question. The next question is 2000 question 24. Question 24. Now, chemical equilibrium is attained when, I still told you, equilibrium means equal. In essence, chemical equality. Okay? I told you that for chemical equality or chemical equilibrium to be attained or achieved, I told you that the product and the reactant must be the same. Must be equal. The product and the reactant must be constant. In essence, they must be equal, they must be the same. So the answer there, the first one says reactant in the system are used up, no. Concentration of the product are greater than, no. Say concentration of the reactants and products remains constant. That is the answer. Now, the next one is 2007, question 10. 2007, let's see question 10. I think so. Now, the difference between the electronegatives of two elements, if the difference between the electronegatives of two elements is large, the type of bond that can be formed between them is, they said if the two elements of the electronegative is large, if it's large, okay, electronegative there, like I said, is the difference of charges when you want to talk about here and now. If they are large, what type of bond, what type of compound, what type of bond will be formed? Okay, remember I told you about intermetallic bonds, I told you about ionic bonds, I told you about dative bond, and I told you about covalent. So the answer there is ionic. Ionic. Ionic talks about electronegative, two charges, different charges, positive and negative. Now the last one, because of time, the last question is 2001. Okay, question 9. They say, which of the following compound is covalent? I told you of covalent bond, of covalent compounds. Okay, covalent bonds are still molecular bonds. Okay, I told you that it is between gases. Between gases. Between gases. It is not between an element, a metal and a gas. I told you it is between gases. It is between non-metals mostly. Okay, non-metals. These covalent bonds or these covalent compounds or this intermolecular or this molecular compound are basically on non-metals. Now, if you check the answer they gave to you, calcium is a metal and chlorine is a non-metal. That's not the answer. Magnesium is a metal, oxygen is a non-metal. No. Sodium is a metal, hydrogen is a non-metal. No. Carbon is a metal, is a non-metal, hydrogen is a non-metal. So the answer is CH subscript 4, which is methane. That is the answer. Why? Because the carbon is a non-metal, hydrogen is a non-metal. And both of them coming together in a covalent bond to form a compound called molecular compound. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.